I'm going to say that again. The way we do these questions is very, very elementary and simple. But it is very tricky, again, in how far it can be taken. Okay? We've already done, notice this is number 3. What was number 1? GCF. What was number 2? Trinomial. Now we're at difference of squares. Now remember, all factoring is the reverse of expansion, right? So expand this for me. What is x times x? X squared. What is x times negative 4? Negative 4x. What is 4 times x? Positive 4x, and 4 times negative 4 is negative 16. Which, when we collect our like terms, gets us x squared plus 0x minus 16. And you have already seen that. Would we ever write 0x? No. So it is x squared minus 16. Now, all of you should recognize that that is exactly what the title of this kind of factoring is, isn't it? What math is that? Subtraction. Subtraction gives me a difference, doesn't it? And it's called difference of squares. Is x squared a square?
Yes.
Yes. Is 16 a square?
Yes.
Yes. So you should be able to see that since you know how to expand it, you reverse it the other way. And you notice that the two factors are x and 4. And you should notice that the first factor, x and x, is if you know the answer, you could say something. The first factor is, that's not supposed to cross out, it was supposed to highlight. X and x are the square root of that. And then you should notice that 4 and 4 are the square root of that. Everybody see? It's easy peasy. Now, I'm going to write something down that, again, is so easy you don't even think about it. But watch what can happen with it. What I'm going to write down is this. Difference of squares is simply some factor squared minus another factor squared. Now, what is 16 really? 4 squared, right? So this and this are the same thing. Understand? This always factors to the square root of a squared plus the square root of b squared, and then the same thing with a minus. No matter what it is. Does everybody understand? Okay? So now we have to talk about some of the finer points. This is one of the finer points. What is the square root of x squared? X. Why? Because this is x times x, yes? So x times x has a square root. What is the square root of x to the 4th? X squared. What is the square root of x to the 6th? X to the 3. What is the square root of x to the 12th? X to the 6th. What is the square root of x to the 6th then? X to the 3. What in all of this where are the only places I cannot go any further? I cannot do a square root of x. I cannot do a square root of x to the 3. What is the square root of x to the 10th? X to the 5th. Can I square root that? No. So what tells you if a variable is a perfect square? Pardon me? Cut what in half? The exponent. And if the exponent, if you can cut it in half, then it must be what kind of number? Even. An exponent, an even exponent has a square root. An odd exponent does not. Everybody understand? That's the first trick that this can throw at you. So let's start with the very first question. Is this a difference of squares? Yes. How do you know? X is an even number, and 1 has a square root, doesn't it? What is the square root of 1? 1. So this must be x to what power? 8 plus 1, and then what? X to the 8th minus 1. Would I stop there? Yes. Look closely. What do you notice about that and that? They're both perfect squares. What do you notice about the operation in the middle? It's another difference of squares, isn't it? So this we can't do anything with. But what's this become? Yes, you do. What did you do with 16 and 1 right here? X to the 4th plus what? 1. And then what? X to the 4th minus 1. Are you done? Why are you not done? It's not weird. Makes perfect sense. What do you notice? There, and there. It's another difference of squares. So what is it? It is what, Harmon? X squared plus 1, and then? What do you notice? There, and there. What's happening here? Same thing again. X plus 1, x minus 1. That's the first trick. Sometimes you have to keep going. Does everybody understand that one? Please notice I've only showed you one of the easier ones because I expect my pre-diploma class to pick this question up in one try. Is that all right? Or have I overestimated? Is everyone okay with this? I just want to make sure. Do these 3 in your head. Do them in your head. Does everybody have an answer for all 3? Is your first answer x plus 3, x minus 3? Excellent. Is your second answer x squared plus 4, x squared minus 4? No. But then, of course, you did x plus 2, x minus 2. And is your answer for the last one x cubed plus 8 and x cubed minus 8? Yeah. And nobody's trying to go any further there because I did this one on purpose because x has a cubed root and 8 is a cube, right? No one's trying to go further there, correct? Hint, hint. Next year, you learn how to go further there.
What?
Yeah, there's a difference of cubes, but you don't have to worry about that till next year. whispering now? Because it's kind of creepy. Okay. All right. Okay. So now, apply your knowledge. Remember, how do I always say to apply your knowledge to a new situation? I say, I say, make it look like something you know, and then extrapolate information from there. If that y wasn't there, what would you have? X plus 15 and x minus 15, correct? If that x wasn't there, what would you have? Y plus 15, y minus 15, correct? Okay. But they're both there. So what do you have? xy, what? Plus 15 and xy minus 15. Easy peasy lemon squeezy. And in 1 second, xy plus 15, xy minus 15. In 1 second, I will show you, does that not still follow the rule? Square root of x squared is x, square root of y squared is y. So xy is the square root of x squared, y squared. Everyone is good? Great. You do number 3, because number 3 looks like it's going to trick you, but isn't. Bong, bong. What is it?
X to the z4.
Z to the fourth.
Z4 minus 12, because there's no square root of 12.
Plus 12. And z to the fourth minus 12. And nobody's going any further. Why, Luke? No square root of 12. Gouda? All right. Again, apply what you know. Look at 4. You already know that if the numbers look weird, that the rule still applies, yes? So, what is the square root of 4x to the 6th? 2x to the 3rd. What is the square root of 5y squared? 5y. And then you just write it again. Easy peasy lemon squeezy, correct? No, you just stop you slow your roll there, big guy. You think I leave this much white space for a reason? Of course I do. What's this one? What's that? Yeah, you can. Oh my God. You're going to tell me that you can't. So what is that?
5 and then x.
So 5x squared, and what's inside there now?
I got you.
Now what? Five x squared, x plus 2, x minus 2. Yeah? Okay. First slightly difficult wrinkle. The first 3 wrinkles are just, you can get rid of them by just pulling it a little tight. You don't even need to iron it. Everybody good? Iron? Who irons?
You could just put it in your bathroom while you're showering. It's gonna iron itself. Like,
The dude who irons his jeans and cheaters.
Next wrinkle. Next wrinkle. x minus 2 squared minus 64. Oh.
X squared minus 4.
This is the wrinkle that you might think about ironing. Like you've hung it, you've taken your shower, and it's still wrinkly. So then you're like, oh crap, I'm just going to throw it in the dryer with a damp face cloth because that'll work too. Hint, hint, I just gave you a cool method of dealing with that. I just gave it to you right there.
I already forgot it.
I know you already forgot it. How many of you want to? There you go. What if I make this m squared minus 64? What's the answer? What's the answer? M plus 8, m minus 8, correct?
Oh, I did that.
But is there any m in the original question? What's m?
I did that without even knowing it.
So isn't this really x minus 2 plus 8? And isn't this really x minus 2 minus 8? What's negative 2 plus 8? And what's negative 2 minus 8? And it's done.
Oh, I didn't do the second step, but I did the first one.
Good. Everybody good? All right, are you ready for the last wrinkle?
I'm done.
Are you ready for the last wrinkle?
Wait. Yeah, I'm thinking.
Are you ready? X minus 3 squared minus, 2x minus 3 squared minus x plus 4 squared. What? What? Good gravy. Hardest kind of difference of square question I can give you, really. Without any GCFing involved. Are these the same anymore?
No.
So can I use one letter?
No, you gotta use two.
I gotta use two letters, don't I? So if I make that A and I make that B, this becomes A squared minus B squared, correct? Which would be A plus B, A minus B, wouldn't it? Is everybody with me to there? Everybody with me to there? Okay, what's A? 2x minus 3. Plus what's B? X plus 4. Plus. What's A? 2x minus 3. And then what is it? Minus what? What? X plus 4. Two x minus 3 minus x plus 4. Now what do you do? Wrong. 2x plus x is what? 3x. Negative 3 plus 4 is what? Positive 1. 2x minus x is what? X. Negative 3 minus 4 is what? Negative 7. And now I'm done. Is everybody good? Now, let's pretend that this method, you don't understand it. I don't think there's anybody in the room that doesn't understand what I'm doing here. But let's pretend you don't understand what I'm doing here and you don't want to say. Your options are as follows. You could expand both of these, collect all the like terms, and factor the resulting polynomial, which will still work. Or you can recognize that the square root of anything squared is just itself. Okay? But I am telling you, this move is very helpful. Everybody good? All right. Your job tonight and over the course of the weekend is to do page 163. $165. I don't know. What's your next page? Does it say assignment number 4, factoring? Does it start with x squared minus 49? What the halibut? That's what you're supposed to be doing next? 1 second.
Is it on the next page? 165. It's assignment number 4 and it's on 165. That's the one you want?
No, yeah, go ahead. Do 163 and 164.
Bro.